Let's see. Is anybody using on Jabber?
I've got the, oh, yeah, that's the chat window.
Oh, okay, I got the chat window. We can just do that's. Oh, that is Jabber. Okay.
Yeah, that's Jabber. So, yeah, I don't think we need a scribe, right?
I don't think so either.
Yeah, that's more useful when we're not virtual. Uh, keep trying to reply to people all the way. Zheng Zhang is still having problems, but I don't know how much longer we can wait for people to get this fixed. There were test sessions, so I think we do need to start pretty soon, though, right?
Yeah, I
Casey?
think so.
Okay. All right. All right, everybody. So this is the LSR working group, as the screen share shows, and our agenda is up there. Does anyone have any problems with the agenda? Okay. So I will bring up the status slides. Let's see if I can do that. Wow, it works. There are a couple people saying they can't hear even with Chrome. I don't know what to do, though. I don't think we can just hold the meeting up.
No, I don't know what to do either. I had a problem with that for about, maybe they could have updated to Big Sur and there could be problems we don't even know about.
I will, there's a reporting problems. And I'll do that and then we'll start. See if that works. Okay. Yeah, if you want to start, AC.
Okay, next slide. Okay, this is, I guess, the first meeting of IETF 109. Be aware of the note well, and that if you, by participating in these meetings, registering and participating in these meetings, you are obliged to disclose any IPR that you are aware of. Also, I mean, it's wider than that. You can just kind of look at the slide. I know most of you have seen this many times before. Okay, next slide. Since IETF 108 virtual, we have 3 RFCs. The ISI's invalid TLV handling. That was good to finally get that all documented and get the IANA updated as to what TLVs were valid for which PDUs. And these two, the two specific link attributes drafts, both for ISIS and OSPF. These are good, especially as we spend a lot of time on these. Those people know that we are involved in. For OSPF, it allows us to get down to many fewer LSAs for all the different applications that we're going to support. I mean, so this is great that these are done. Next slide. We have the same drafts with missed references, the two Yang models, OSPF and ISIS, and the tunnel end caps. Now, the tunnel end caps appears to me moving along in IDR. They got a new editor. Thanks you, John. And hopefully it'll be published soon, and that'll go. Now, another thing about these drafts, these three drafts, these are the last ones that don't have LSR in the name. So after this, we'll have finished all the work when we had separate ISIS and OSPF working groups. Next slide. I guess we have these two that are waiting on the segment routing, BGP-LS segment routing extensions, the ISIS and OSPF ELC advertisement. That's entropy label capability. Next slide. We completed the last call on the ISIS SRv6 extension. We just completed the Flex algorithm working group last call, and the prefix originator is pretty close to complete. We had some discussions on differences with the similar document in ISIS just recently, but that should go forward as well. Next slide. I think for the OSPF and ISIS segment routing, the MPLS-based segment routing, Yang models are also ready. I'm an offer on that. We'll probably last call them before the next IETF. Additionally, the reverse metric, that's augmentation to the ISIS Yang model that's on the RFCQ. I think I'll working group last call that one probably within the next few weeks. And extended LSAs, I think this is also ready. I'm also offer on that. Next slide.
Yeah, I was gonna mention my mic didn't unmute last time, but on the prefix originator, I'm Shepard on that one, and it's ready to go. When it went into working group last call, there was some contention over some use cases being removed, and that got resolved. The use cases were removed. So if anybody, we'll be ending the last call very soon. So if there are any more objections, then please post them. I don't believe there are. I think that it's ready to go. But just in case, get your objection in fast.
Right. Okay, we have these existing working group documents. The dynamic flooding, it seems that at least we might have some implementations in progress. It's a foundation for other drafts. So hopefully we can have some good discussion on that one during the next couple months, and maybe working group last call it. The hierarchy, we probably won't move forward with that right now because it's a pretty complicated, not complex, but it's a major protocol enhancement. So if nobody's going to implement it, I don't know that it makes sense to working group last call it and move it forward. And then
yeah, this is one of those ones that you might, that it really does help maybe to get some implementations. or
That's right,
an
right. I don't think,
implementation experience.
yeah, I agree. And we have a flooding algorithm, a documented flooding algorithm for the distributed case that's based on the first draft, the flooding on dense graphs draft. Next slide. We have all the, let's see, is there anything? That was an accomplishment. We decided to go forward with experimental drafts for flooding reduction, and we accepted 3 pieces of work: the area proxy, the flood reflection for ISIS, and the ISIS TTZ. We also have, I probably shouldn't have listed the second one. This is a mistake. It shouldn't be a new working group document. It's been a long time. And I need to make sure, I saw that the authors refreshed it, make sure there's still interest in this. It's pretty much just a protocol maintenance draft where for PC, we have PCE and the capabilities. This, whether, you know, where the PCE capabilities of a server and clients. And what this does is it allows you to also discover what type of security is supported. The Yang model augmentations. For this first cut of augmentation supporting drafts that weren't in the OSPF model, we probably won't go forward. We'll probably want to get at least a few more augmentations in that before we publish that, or at least go forward before we can go last call. Next slide. And we got these working group documents. Let's see if there's any. Yeah, there's one. These are ones we added since the last IETF, or right before the last IETF. The OSPF v3 extensions for SRv6. I believe there's a reference to that in Flex algorithm. So we might want to give that a priority. And as I don't know if anybody's implemented it. I'll start a discussion on that one, just because there's a normative reference in the Flex algorithm draft. A lot of these other ones, like reverse metric and link bundles, there's things that are in ISIS that we're putting the comparable function in into OSPF. You can see I must have thought that the OSPF SR6 extensions was important because I listed it twice. And we just accepted ISIS RFC 5316 BIS. This allows you to support 5316 in IPv6 only networks. The GMPLS extensions in IPv6 only networks. Previously, you required the routers to have, the encodings required the routers to have an IPv4 address. Next slide. We got quite a backlog. I think all of these, we'd like all the authors have asked for working group adoption. I think there's a good reason to adopt all of them. The flooding parameter advertisement, I expect that to generate working group discussion again, but it's definitely been presented enough times, and it's time we discuss it, discuss it and possibly adopt this document or some form of it. And I believe that's all.
Yep. Any comments? If not, we'll move to the flooding results. Okay. Okay. What happens when I close the window? Oh, perfect. Okay, go ahead.
Yeah. Hello?
Yep, we can hear you.
Can you hear me?
Yep.
Yeah, I'm Yan Gang. Hello?
Yes, we can hear you.
Okay. Shall I start it?
Yep.
Okay, thank you. Okay, hello, everybody. Here is Yan Gang from Huawei. Okay, next page, please. Okay, right now, IETF IRSA working group have several drafts related to IGP flooding processing. So there are two directions. One is to reduce flooding amount by using flooding topologic, and another is to reduce retransmission and speed up flooding. So we try to do some flooding test, and hope it can provide some help to optimize IGP flood. This is the menu. So the first I introduce our motivation, and then is test scenario and the test case. Finally, it is our conclusion. Next page, please. So this test adjust some flooding parameters, try to achieve minimum flooding time and minimum retransmission amount. Okay, what we adjust are listed here. The first parameter is window. It is similar with interface RSP receive window in flooding speed draft. It is the threshold of retransmission queue. And the next one is TX interval. It is to control retransmission timer. The last one is interface TX interval. It is RSP sending speed. So the process of our test is similar with flooding speed draft, but we don't implement the draft, just use configuration to simulate the process that the sender side receives those parameters, and we check the result. So next page, please. Okay, I introduce our test case. Here we have 3 test cases, and the case 1 want to find the impact of retransmission interval, and the case 2 want to find the impact of interface RSP receive window, and case 3 is based on the case 2, and the dynamic rate control is added. And here we in our test case, there are 3 kind of device: tester, sender, and receiver. The tester generate 20,000 RSPs and send to sender. The sender flood those RSPs to receiver. And we have 3 scenarios: single link, parallel link, and dual home network. Okay, next page, please. So the first is case 1. We change the TX interval. It is retransmit interval. In this case, no interface RSP receive window, and the interface TX interval is 100 RSPs per 100 milliseconds. TX interval is set as 1 second, 3 seconds, and 5 seconds. We can find the flooding timer is similar. Runtime is similar. The impact of this factor to the flooding timer is small, but small TX interval will increase the retransmission amount. Okay, next page, please. So the case 2, we test interface RSP receive window. Now this test case is only executed on the scenario 1 single link. Here we have two kinds of rate. Default rate is 100 RSPs per 100 milliseconds. The minimum rate is 10 RSPs per 100 milliseconds. Interface TX interval will be set to default rate in default, and set to minimum rate when number of unacknowledged RSPs reach threshold. The interface RSP receive window. Through this test case result, we can find one proper interface RSP receive window can effectively reduce the number of retransmit RSPs on the interface, but the flooding time is not so good. So next page, please. To case 3, based on the case 2, we change the interface TX interval from static control to dynamic control. The process is, if the number of unacknowledged RSPs reach interface RSP receive window, decrease the rate by 50%. Otherwise, increase the rate by 20% until 200 RSPs per 100 milliseconds. Here, the interval is 1 second. You can see the number 2 and the number 3, the flooding timer improvement is obvious. And number 4, we think the speed keeps rising because the sending RSPs have not reached the threshold. So dynamic speed adjustment based on the static window significantly reduce the RSP flooding time and the number of retransmit RSPs. So, okay, next page, please. Based on these 3 test cases, we get some conclusion. The first one is the sender should be aware of the capability and the processing status of the receiver to control the flooding time and the number of retransmission. And the second is, if only the static window is used to control the transmit rate of the sender, the number of retransmission can be reduced, but the flooding time will be prolonged. If the window size we set is too small, the flooding time would be too long. If the window size is too large, the upper limit of the window cannot be reached, and the flooding speed on the interface keeps rising until maximum. Adaptive learning is required to obtain an appropriate window size. Dynamic adjustment of the flooding of the sending speed based on the appropriate window can achieve better flooding time and better RSP transmissions. It is our conclusion. Next page, please. Actually, we are keep on put more effort. We are put more effort on the flooding process. We will keep on doing it. So actually, we also need more input and the suggestion about this test. Yeah, it's all. Any suggestion?
Yeah, go ahead, Les.
Yeah.
This is Les Ginsberg from Cisco. Just a couple of quick questions. Did you do any adjustment to?
This is Gian. Can you hear me?
Sorry, can you folks hear me?
Yeah, Les, I can.
Can everyone hear me?
We can hear. Yeah, we can hear you, but you're cutting in front of Les.
So Can I
Was
go
there any
ahead, Chris?
special equipment used for the testing or?
So, Chris, do I still have the floor here?
You do. I suspect he can't hear us.
Okay, so the question I want to ask is, did you do any adjustment to the PSNP response time? Because there was a presentation last time from Sarah and Tony that indicated that that made a big difference.
Right now in our test, okay, PSNP, its interval is constant in the standard, it is 5 seconds. But right now in our test, we set it to 800 milliseconds. We think it is already small enough, and we try to send the egg as soon as possible.
Okay, second quick question is the receive window that you talk about, what you're actually doing is just monitoring the local retransmission queue for each interface, correct?
Yes, about this issue, actually, we also discuss it internally. Okay, we need to get this kind of control. So the queue size, the unacknowledged queue size, it is one condition, and how to say that? Also, we also can get some feedback from the receiver side. All of this is possible because sometimes, especially in SS, some scenario no enough information to control it. Sometimes on some interface, we can just check the queue size. Some condition maybe we need the receiver side feedback some information.
Okay, I just wanted to clarify what you actually did in your test. Thanks.
Okay, thank you.
Okay, Gian?
When he turns his audio on, when he turns his mic on, he can't hear anymore, apparently.
Pardon?
Yeah, Gian, I was speaking of Gian Mishra.
You hear me now?
Okay.
Yes, we can hear you.
Hello? Hello? Can you hear me? Hello? I'm gonna turn it off.
Yeah. Gian, just try asking your question in Jabber. Got about a minute left. Bruno, go ahead.
Bruno from Orange. Do you hear me?
Yes.
Yes.
And thank you for the test. Very useful. Similar comment compared to today's. When you do the test with a static window, it would be useful to acknowledge the LSP, the received LSP faster, as illustrated by Sarah and Tony 1 or 2 years ago, because it allows you to have a dynamic acknowledgement and dynamic adaptation of the window. So if you want to do more tests, it would be interesting to acknowledge the LSPs every few LSPs. Sarah and Tony proposed 15. Thank you.
Thanks, Bruno. Guillen's question is from Jabber now was the testing done with software-based simulation or was it done with hardware?
So about next step, we will keep on get more suggestion and try to do more test case. And right now, for the case 2 and case 3, we only test the single link. Maybe next step we will confirm. We will test it on the Paralink and the dual home network, because in the single link, the parameter adjustment is simple. But when the tester device have many peers, so it means all of this parameter, its adjustment will be more difficult. I think next step we will test complex scenario, Paralink and dual home network. Even all of this kind of scenario is mixed.
Gang, though, did you use a hardware like router hardware, or did you use a software simulation to do your testing?
We test it in Huawei hardware.
Okay,
directly.
thank you. That was Guillen's question. Thank you.
Yeah.
Is you song? Okay. We need to wrap this up, unfortunately. Is you song? Yeah, you can't be heard. So we're gonna move to the next one because we're 2 or 3 minutes over.
G's gonna do it. G's gonna do it.
Okay.
Yes.
Thank you, Gang.
Okay, thank you. I mute my mic.
Hi, AC. Hi, Chris. Can you hear me?
Yes.
Okay, great. Okay, I will present this on behalf of Yongqing because they have some network problem. We cannot log in to this meeting. Okay. So this topic is about using FluxAlgo for segment routing based VTN. Here are the draft. This is a version 01, and here are the co-authors. Okay, next page. Okay, here are some background about this work. We introduced this term VTN in the draft IETF-TS enhanced VPN. Basically, it is a virtual underlay network with the required topology and resource characteristics. And then we introduced a term resource-aware seeds in draft IETF Spring resource-aware segments, so that the SRCs can be used to represent different sets of resources allocated for the packet processing. Then we have this SR for VPN Plus described in the Spring draft SR for enhanced VPN. Basically, it describes the mechanism to build SR-based VPN with resource-aware seeds. Then we think this draft is more focusing on the control plane mechanisms, more specifically how to use FluxAlgo-based mechanism to distribute the information for the per VPN specific topology and resource attributes to network nodes, and also can be collected to the network controller. Okay, next page, please. Okay, this is the mechanism we use in this draft. Basically, we reuse the FluxAlgo ID as the control plane identifier of a VPN, so that we can use a FluxAlgo mechanism to describe the topology constraints of a VPN. And we can also use the ISS extension, segment routing extensions to advertise the algorithm-specific prefixes or SRv6 locators. Then we also need some mechanism to advertise the T attributes associated with HVTN. Here are the extensions. We use the ISS-L2 bundle with some extension to advertise the T attributes for HVTN. And we had made some small extension to the L2 bundle to make it applicable for both physical and virtual memory links. We introduce a new flag V to indicate the memory link are virtual links. And so that we can associate the VTN with one or more physical or virtual memory links in a bundle interface. We need to use the admin group or the extended admin group to correlate a flux algo and the memory links, so that the T attributes and the seed attributes advertised for the memory link will belong to the corresponding VTN, so that the VTN can have this kind of information for the controller and for the computation of the path. Okay, next page. Here are the updates in this version. Basically, we didn't make a significant change to the mechanism. The mechanism is stable since the 0.0 version. In this version, we add some description about the forwarding plane behaviors, about VTN-specific prefixes and adjacencies. We also add a reference to the IETF Spring resource-aware segment draft, because the resource-aware seeds are used in the data plane of this SR-based VTN. There are also some editorial changes to improve the readability. Next page, please. Okay, for the next steps, the authors think this mechanism and the content are straightforward and is stable, so that we would like to ask for working group adoption of this document. Okay, that's all. Thanks.
Jay, just speaking as chair, can you start a thread with some more discussion on this draft before we see if get people to read it and socialize it? I know it's been around. I read it and I understood it all, except the need for the V flag wasn't clear to me. That part of it wasn't clear, but.
Okay, you mean we can start to have more discussion on the mail list and then have the adoption started on the list?
Right, and this was the first time I'd read it. I mean, I read it rather quickly. I see we have Peter on the queue.
Okay.
Go ahead, Peter.
Can you guys hear me?
Yes.
Okay. Okay, I commented on this earlier on the list. The way the flux algo constraints are being used for the bundle members is very limited. It's saying the complete truth.
Yeah, yes, I understood. Hi, Peter. I think we had a discussion on the list, and we will explicitly mention that restriction in the next version of this draft. And I think that's a good point. Thank you.
All right.
Okay. AC, by the way, I'm muting so I can type. So if you want to handle the queue, that'd be great. I think we're ready for the next presentation.
Yep. Okay. I think we're ready for the next presentation. Again, yeah. Let's take this let's take this discussion to the list. I don't think too many people have read it. In the
Okay,
interest
thank
of
you.
time, we won't use the show of hands tool. So next on the agenda is another VTN draft, this time using the informational draft, just using multi-topology.
Okay. Can you hear me?
Yes.
Okay, thank you. Shall I start, right?
Yes, go ahead.
Okay. Yeah, this presentation about using ISS multi-topology for routing-based VPN. Enhanced VPN is the enhancement to existing VPN service to support the needs of new applications. So it can be considered as an evolution of traditional VPN. But with additional service-specific commitments such as isolation and performance guarantee. So it may be using 5G transport network slicing and other generic scenarios. Next. This is background. The draft proposed to reuse MIT-ID as a control plane identifier of VTN. So VTN has been introduced in the previous slides. So it is a virtual analytic network with the required topology and reuse resource characteristics. Also, resource-aware segments is defined resource-aware state. So SRC can represent different set resource allocated for packet processing. The third draft is about the second routing for enhanced VPN. It is described the mechanisms to build SR-based VPNs with resource-aware states. So in this, the mechanisms described in this document assume that each VPN has a dependent topology, so that the VPN can be identified using the corresponding MIT-IDs. Next. This is the introduction about the mechanisms of this draft. RFC 5120 has been defined to create a dependent topology in one network with a single ISS domain, a set of dependent topologies that we call MT topology, MT. This medical extension can be used for a variety of purposes. It also been capable specifying customized attributes of each topology. When each VPN has a dependent network topology, the MT-ID could be used as an identifier of the VPN in the control plane. RFC 8667 describes the IS extensions that need to be introduced for segment routing operating on an MPS data plane. The draft SRv6 extension describes the ISS extensions to advertise topology-specific SRv6 locator and states. So, in order to perform the constraint-based path computation for each VPN on the network controller or egress node, the network resource attributes associated with each VPN need to be advertised. When maximum link bandwidth sub-TLV is carrying the MT as an TLV of topology, it indicates that amount of link bandwidth allocated to the corresponding VPN. The bandwidth allocated to a VPN can be exclusive for service carrying the corresponding VPN. Next. So this document was presented in IETF 108 in ILSA working group. Based on the discussion and the suggestion from the working group, the document type is changed to informational. And the descriptions about the forwarding plane behavior is added in the new text. Continuous results aware state are used in the data plane of SRVPN. So the draft of sprint results aware segments is added to the reference section. We also made editorial changes based on the comments. Next. So for the time being, the content of document is stable. Document type is now informational. The previous one is standard track. We now change it to the informational. So we would like to ask the working group to adopt this document. This document received a lot of comments from different people within ISR. We really appreciate that. Thank you. This is it.
Any comments on the draft? Anybody? I think this one's more straightforward than the other one. I guess
Yes.
we could put it in the queue for adoption myself. That's my opinion, speaking as a working group member, but we can, I think we could do it. The only question would be whether it's needed, and I think it's good to have an informational draft explaining this myself.
So we have a few minutes and nobody's in the queue. Do you want to try to use the hand thing?
Okay. No.
All right. Do you remember how to do this? Okay, show of hands tool. All right, so the question, there's a show of hands tool on the left side. The question is, do people support adopting this draft? Okay. So, like I said, there's on where the participants are normally listed, you click on the little bar chart, and then you can raise your hand. Looks like people are understanding it. We have 15, 16 voters. Yeah, we don't vote, but we raise hands. Okay, so everyone will see the results when I hit the end, I think. I don't know if people see it right now.
I can see it.
Yeah, because only the chairs can see it, I think.
Oh, yeah, chairs, right. I think only the chairs can see it.
Oh, Joel says they're visible. Okay. Awesome, great. Oh, it's still changing. All right. There are a bunch of people in the queue now. Do you want to call them out, Casey?
Yeah.
I'll end this. Okay, it ended.
Okay, remove from. I can't remove myself from the queue. Can you remove me?
Oh yeah, no, I mean, I think we should have called them to talk.
Yeah. No, I'm gonna get Gian. Do you want to send audio?
I'm sending
Ian?
audio.
Okay, we can hear you.
Can you hear me?
Yes.
Can you hear me?
Yes.
Oh my goodness. Can you hear me?
Yes.
I can't hear anybody else.
Okay.
Can we move to Loa?
Yeah. Loa, can you send audio?
Hello? Can you hear me?
Mm.
Loa? Can you can speak, Loa?
Sorry, you're asking me something.
Yeah, you were in the queue. Maybe it was a mistake.
Ah, okay, that must have been a mistake. Thank you.
Okay.
Okay. All right. Well, we're out of time on this slot. Let's move to the next one. So it sounds like we can ask for adoption on the list. It was pretty well supported by the call of hands too. Not necessarily that it will get adopted, but you know, it's worth probably putting it out there. All right, let's move on. I think.
Thank you.
Thank you. This will be you, AC.
Yes. I'll try and go fast. Oh, yeah. Okay, you can move forward. I'll talk to this on the next slide. Okay, this is a very old draft that we dropped work on, the transport instance. And there were really two motivations for reviving it. The first one was there's the mechanism in ISI known as the GenApp draft, or the generic ISI instance. RFC 6823 did go forward, and it seems like a recurring theme now is to advertise using the IGPs to advertise information that's really not related to routing, so we revived it. Next slide. There's a number of use cases, some of them being presented at this IETF or past IETF, some that are in the queue where where people are proposing to advertise non-routing information in OSPF. And that would be one use case. This is one use case on here is the multi-axis edge computing for service discovery of servers supporting various services. Another one, we've also had some discussions of putting more information into LSAs so that the information could be exposed across areas. Now there's a number of ways you could do it. You could run more BGPLS sessions, but another way to do it, you could use the transport instance and send this information from other areas just for BGPLS purposes in the transport instance session. These are hypothetical. This draft isn't about this, but next slide. So what is a transport instance? A transport instance is a parallel session, or I mean, you set up separate OSPF adjacencies, and you do not send normal routing topology on them. You can do this, and you can use the same links because the OSPF packets have an instance ID already. The OSPF v3 has always had one, but OSPF v2 you'd use RFC 6549, which supports it's an extension to the packet formats to support an instance ID. So you can differentiate, demux the packets, when the OSPF packets, to the regular routing instance and the transport instance. As a the relationship to normal OSPF instance is it ships in the night. You may want to use, depending on the information that's being, non-routing information that's being transferred, you may want to have the condition of reachability where you wouldn't want to use the information unless the node that advertised it was reachable in the normal routing plane, in the plane. That depends on now how strict you want to be is dependent on what this application data is. And you could also, if you didn't want to impact the packets on the wire, you could make these lower priority for the transport instance. Next slide. Okay, one thing about the transport instance, you don't install any routes. So we will have the topological LSAs just so you can debug it and you know what OSPF routers make up the topology for dissemination of information in the transport instance, but you wouldn't have any of these other LSAs and you would not install any routes into the RIB. Next slide. Now, one thing that's interesting about this, you can support sparse topologies. In other words, you don't have to have the same OSPF routers connected to one another. I mean, you don't have to have the same set of sessions for the transport instance as your normal OSPF instances. And you can also support the concept of a pre-configured OSPF neighbor that is more than one hop away. So you have a remote neighbor, which is pretty powerful because you think about it. One of the problems with putting things in the IGPs is every router gets it when only a small subset of the routers need to get it. With the transport instance, you could say have a controller and it could have OSPF remote neighbor sessions with only those OSPF routers that need to have this information, whatever it is. Now, the concept of multi-topologies for routing isn't applicable, but you could have even multiple transport instances for different types of data with different types of different topologies when I'm for disseminating this information. Next slide. We're using the same encoding that we use in all the OSPF TLVs. It dates back to RFC 3630. And it was carried into the opaque LSAs. Well, in OSPF v2, you would use the opaque LSAs, and in OSPF v3, because OSPF v3, it's very easy to allocate new LSAs in a backward compatible fashion. You'd preferably define new LSAs for this data. Conceivably, one could use the extended LSAs and piggyback on the normal ones, but I think it would be better to keep this information separate. We can take it as a case-by-case basis as applications are defined to use the transport instance. Next slide. I think this is the last one. Here's just one that we had talked about. I had talked about with Ying Zhen, is for this multi-axis edge computing to identify the servers. And you could put this in an OSPF v2 opaque LSA and an OSPF v3, a new LSA type. You'd identify the servers by their application address, that's address, and you'd have a service ID for the type of services, and then you'd have CPU usage and the thresholds. This is just one example, but you could use this for many different things. Last slide. Okay, we're going to see if there's interest in this. And right now, we're not asking for working group adoption. We're just going to ask for comments and see if people are interested in using this.
Aijing,
Hello. So, how about put the information in one independent top tier LV, which can be only be included in the router LSA, so we need not define the separate OSPF instance.
I guess it depends on what the information is that you want to put in the router LSA.
Yeah, currently you just mentioned some information related to the server. So I think it has a similar application for another draft that is provided by the Linda. So I think we can try to put the information in one independent TLV. I think it may be more simple for your solution.
yeah, I think that this should be discussed on the list for sure, especially in the context of some of the presentations today coming up later that I think you're referring to.
Okay.
Okay, Les?
Just, I didn't realize until just now that you had revived this. 6823 introduced an application identifier with a registry, to control the assignment of the applications. Do you think that that concept has any relevance here?
Yeah, let me look at that. We'll take a look at that.
And maybe we'd have to change things a bit, but maybe we could share the registry between the two IGPs.
Yeah.
Okay, thanks.
Robin was in the queue too. I removed him by mistake. I see he's back in the queue.
Go ahead. Got it. Not yet.
Robin?
Can you hear me? Please. Hello?
Yes, we can hear
Okay. Okay, I see. I have the similar concern as Aijun, because from my point of view, because introduce an instance, because I think this provide the complexity for the network evolution, because this may introduce more configuration. Because we know the BGP, they always use the same session to support the different services. So from my point of view, maybe we can also take the similar mechanism and also use for the better network evolution, and also reduce the possible the cost of the IGP. So that's my comments on this draft.
Thank you. Guyan, I don't know, do you really think that you fixed things? You're in the queue again. I do, we're 4 minutes over, so I think we have to cut now and move to the next presentation.
Can you hear me?
Yes, we can hear you.
Okay, all right. I think I fixed the issue. I just in my headset. So yeah, the question I had was, could this, I guess with this feature, it seems similar to like, I guess like an ISIS multi-topology, I guess, or let's say Flex Algo. Would it work, let's say, in conjunction with, let's say the layering concept where you can do like multiple sparse instances? And let's say if you had Flex Algo as well, would it, could you use it to leverage, I guess, in some way, or maybe instead of using a normal IGP instance, I guess, use leverage Flex Algo, or I guess use this in conjunction, I guess, possibly with Flex Algo.
I don't think so, because this is about distribution of information, not computing different paths. The transport instance is for information that isn't for routing.
Okay.
It's actually really, it's a direct analogous draft to what's in ISIS Gen app. I don't know, I have the RFC off the top of my head.
I got you. So it's really just transport, I guess, right? No routing construct. Gotcha. Okay.
Yep.
Thanks.
All right, we need to move to the next presentation. Thanks, AC.
Thanks.
This is
Hello, everyone.
Flex algorithm. Yes, we can hear you. Hang on.
Parag Kanaria will present this for me.
Okay, that's great.
Parag, you're up.
Hello, Christian. Can you hear me? I can't hear your voice, Christian.
We can hear you. Yes, we can hear you.
Okay. Yeah. So let's get started. Welcome all to the presentation. This is Parag Kanaria from Juniper Network, presenting the draft Flex algorithm in IP network on behalf of the authors. Next slide, please. So this is the agenda of today's presentation. We will go through over the introduction, use case, and proposed solutions, and that will be covered in the next slides. Next slides, please. Okay, to the introduction. So currently the IGP Flex algorithm compute the constraint-based part to the segment routing data plane, which is like SRMPLS and SRv6. So therefore, the IGP Flex algorithm cannot be deployed in the absence of SRMPLS and SRv6. So idea of this draft is to extend the IGP Flex algorithm, allowing it to compute the constraint-based part to the IPv4 or IPv6 prefix in the IP networks. So with this draft, we can deploy the Flex algorithm in the IP network in the absence of SRMPLS and SRv6. So this covers the intention of this draft. Next slide, please. Now, how do we associate prefix with the IP Flex algorithm? This can be done via the egress node procedure. So the loopback interface is associated with one or more IP addresses, right? So each of these loopback address is associated with the Flex algo. So we can associate one loopback address with the IP Flex algo. So if packet sent to that loopback address associate with the particular Flex algo, it follows the constraint-based path calculated by IGP during the computation. Otherwise, the packet follows the IGP least cost path. Yeah, next slide, please. So one more thing, like association of this address to the IP Flex algorithm is implementation independent. Operator is free to choose existing mechanism or any new mechanism for the IP address to the Flex algo association. Now coming to the advertising part of the IP Flex algorithm, each participating node advertise an IP algorithm sub TLV. This is new sub TLV defined in the draft. So for the ISIS, this sub TLV will be present in the router capability TLV, and for the OSPF, it will go as a router information LSA. So the participating router, by sending this TLV, intend to participate in a particular IP Flex algo throughout the domain. Next slide, please. So advertising the Flex algo definition. All the router participating in the IP Flex algo must agree on the Flex algo, common Flex algo definition. the selected node within the IGP domain advertise the Fed which are agreed by all the node. And for the IP flex algorithm, we can leverage the Fed protocol machinery defined in the Internet Draft LSR flex algo based on the section 5, 6, and 7. So this new IP flex algo will use the flex algo machinery, which is already well defined in the Fed algorithm. Next slide, please. So we have set the common ground by advertising the Fed and the IP flex algorithm throughout the IGP domain. Now we have to associate the prefix with the IP flex algorithm, and we have to advertise reachability throughout the IGP. So to be able to associate IP and IPv6 prefix with flex algorithm, a new top level TLV defined in the ISIS. These TLV are the IPv4 algorithm prefix reachability TLV and IPv6 algorithm prefix reachability TLV. We cannot use the existing prefix reachability TLV because by default it is associated with the algo 0 in the IGP, right? So we have carved out 2 new TLV for the sending a reachability of IP flex algo TLV. So this new TLV share the same set of the sub TLV space defined in TLV 135, 235, 236, and 237. The point to note here is like the whole sub TLV of these TLVs cannot be applicable. For example, prefix segment identifier cannot be part of this IP flex algo TLV. So now let us look at the body of this TLV. It has a metric and the associated flex algo and the prefix and prefix length, and the bunch of, if there are present sub TLV, it will go in sub TLV fields. Just a point to note here is I have not defined the type and length. Just a moment. Yeah. So the point to note here is like due to the space constraint in this slide, I have not defined the type and length field of this new TLV, but it is well present in the draft. Yeah, next slide, please. So similarly for OSPF, we have to define a new TLV for the OSPF v2. This is and this TLV go as a OSPF v2 extend opaque LSA for the OSPF topologies, and it has like MTID algorithm, prefix, metrics, and other sub TLV of that TLV. Next slide, please. So now on the calculating part of this IP flex algorithm TLV algorithm draft, right? So as we know that the IP flex algorithm is yet another application of this flex algorithm. It follows the same procedure of the calculating the constraint-based path defined in the Internet Draft LSR flex algorithm in the section 10, 11, and 12. So when the IP flex algorithm compute to a node, it must use the corresponding flex algorithm participation algo, and it compute the constraint-based path, which is independent of the underlying SR or SRv6 path algo if present. And this IP flex algorithm can use the LFA protection mechanism, which is well defined in the IGP. Also, the SR segment routing flex algo and the IP flex algo go parallelly in the network. If there is a need arise, they cannot interfere each other because they advertise different flex algo. Okay, next slide, please. So since this draft use the existing mechanism of the LSR flex algo draft, and that is very stable as of now, so author would like to request for call for the adoption of this draft. Next slide, please. The author would like to thank you IETF for giving opportunity to present this draft. I would like to ask for any comments, suggestions. So thank you once again. Hello?
Yes, AC, you're in the queue.
Okay, okay.
Just
Yeah,
hang out a minute.
Yeah, this is AC. Why did you define a new top level TLV for OSPF extended prefix LSA? Do you mean? I guess I was wondering why you just didn't use the existing one. I'm not saying it's wrong. I was just wondering the reasoning.
For the OSPF, right? So you mean to say we can use the existing OSPF TLV for the same, but that is specific to the Algo 0, right?
Oh, okay.
So
But
AC,
here we,
if I can jump here, we can't use
Yeah.
the
Yeah, yeah.
existing one because the existing one would advertise the Algo 0 reachability.
Okay.
Okay, Gian.
Can you hear me?
Barely.
All right. Trying to test before the next, before I have to speak. Okay. Okay, let me turn the volume up one little. Okay. Yeah, so the question I had was, how would, I guess, interoperability work with, segment routing? I think you may have mentioned, but let's say if you wanted to use, this, and let's say with SRv6, which, reuses the IPv6 data plane, would this be used in conjunction, or how would this work, I guess, with the Flex algo that's utilized for SR? I guess, and would there be any benefit or reason to that?
So I think voice was not clear, but let me repeat it. Like the Gyan was asking, how does it benefit to the SRMPLS?
SRv6. So let's say using it with SRv6. Since SRv6 uses the IPv6 data plane, could this be used with SRv6?
But this draft is independent of the any existing SRMPLS or SRv6, right? Maybe the operator, if they doesn't want to run or they don't have this hardware capability, they can use this software-based programming in the hardware and can achieve the same level of the data plane separation or the network slicing.
May I add to that?
Yeah, Aaron.
So long as the addresses that you bind to FlexAlgo are different from the locators that you bind to FlexAlgo, you should be able to run them both at once. But the question is, why would you ever run them both at once?
Right. I mean, I guess if you had multiple topologies, I guess, and maybe you had different layers, if you're running ISIS multi-topology or different instances. But I agree. It would be a very corner case that you would do that.
Correct me if I'm wrong here, Ron, but I thought this is kind of like an alternative to SR, right?
Yes. That's why I ask, why would you ever run them both at once?
Right.
No,
Okay.
it's agreed. Agreed.
Yeah.
Agreed. That is just an idea. I agree that you wouldn't. You'd pick one or the other, but it's a thought.
Okay, thanks. Bruno, you're up.
Thank you for the presentation. I haven't read draft 01, sorry for that. The question is specific to ISIS on IPv6. And when reading draft 000, it seems that what you're trying to do, which is useful, is already available. It is currently called SRv6 FlexAlgo, but it doesn't use any SRv6 SRH, so it's only IPv6. So for IPv6, it seems already available. So why do you need to define a new TLV for ISIS IPv6?
So you mean to say why there is a different TLV for IPv4 and IPv6 in ISIS?
No, I mean, why there is a different TLVs between IP Flex Algo IPv6 and SRv6 Flex Algo?
But see, the SRv6 have a, so yeah, hello.
I hear you.
Go ahead.
So the SRv6 sub TLV has like sub TLV has like NSEED and other stuff, right, which are not applicable here, right? So we cannot use the same TLV of SRv6 for IPv6. Or maybe Peter, can you add anything?
Yeah, I guess in theory, one could do that and use the locator TLV without the SIDs. That is not prohibited at the moment, so one can do it. I don't think that would be, from the encoding perspective, that would really be something that I would prefer, but theoretically you can advertise the locator without any SID and treat it as IPv6 prefix. Whether we want to do it or not, I would rather not to. I would prefer to have a clean encoding and not mixing things, but in theory you can do that. It's up to the
So locators
Is
are not 128-bit, right? Here it's
locator is an address.
yeah, but that cannot be a 128-bit address, I guess, as Shraddha pointed.
Well, in theory, it has a prefix and a mask, so it can be. I'm not suggesting we to do that. I don't like it, but in theory, one can do that.
But by theory, do you mean that some implementation would not support, or?
No. Basically, Bruno, what you're asking is why we are not using the locator TLV, right? That's the question.
Yes.
Yeah. Well, as I said, one can do that. I don't think we want to do it, but the functionality is there. Yes.
Okay.
Okay, thanks.
I see.
Peter, did you have something else to say?
No.
Yeah, okay, Tony, you're up. You will have to unmute yourself. The little mic up on the left side. There we go.
Hi, I noticed you just published the -01 draft with less than 24 hours before the meeting. And I was wondering if you could quickly summarize the changes.
So in the draft 01, right, we have merged in earlier draft, we have not counted the empty ID. We have 4 different top level TLV. Now we have merged to the 2 TLV. The top level TLV of the IPv4 and IPv6 header, which contain the empty ID of 12 bits and some reserve bit. So with that, we can use this, we can reduce the number of top TLV to 2, and which also cover the empty ID multi-topology instance also. I think other than that, there is just editorial changes, not much.
Okay, thanks. G, you're up.
Hi. Yeah, I think, can you hear me?
Yep.
Okay. I think I sent some comments to the list. Here I want to restate. I think basically you define a new application to use Flux Algo. And my question is, can different applications use the same Flux Algo ID? And if so, can the past computation result be shared, or the past computation should be done for each application, even if the Flux Algo ID is the same?
No, I think it's not good to use the same flux algo, right? And then there is a conflict happen, right? Which one to prefer for the forwarding? So the draft.
So strictly speaking, Parag, interrupt you. You can. It's completely valid and need to run set up a calculation for each application. Nothing to you to use the same flex algo. It works.
Okay, but the computation for the same flux algo with different application will be different, the result?
Yes.
Right?
And if you read the draft, the latest version, yeah, we just published it. There's a section that describes that.
Okay, okay.
Okay, thanks. Katan, we're out of time, so we're gonna cut the line right here. Your last up.
Very quick thing is Ketan Talaulikar, Cisco. I actually support the fresh, new TLVs and encoding, not to mix with the existing prefix reachability and even the SRv6 locator. I think this is also because for SRv6, the participation is advertised by the SR algorithm, whereas here we have the IP algorithm. So I think it's better to keep them separate, just cleaner.
Thanks, Ketan.
AC, did you have any
Okay.
comments on the adoption request there? Do you think it's ready for that, or
this generated with applications and using in parallel with SRV, it generated a lot of interest already, probably over 100 emails. I think it would be ready for adoption just based on the interest. That was my opinion.
Okay, unfortunately, we don't have time to do the show of hands, so it sounds like we may be moving forward with that then.
Yeah, and I was just going to say, I looked again just when as we were speaking, and I agree that separate TLVs are top level TLVs are the way to go for OSPF.
Okay, thanks, Parag.
Thanks.
Thank you, Chair.
Who's up next?
Hop by hop.
Yeah, hop by hop. Yali.
Hi, I see.
We can hear you.
Oh, thank you. Hello, everyone. My name is Yali Wang from Huawei, and nice to hear you guys all. And I will present this new draft about the IGP extensions for advertising the hop-by-hop options header processing action. And next, please. Okay. So as specified in RVC 18.2.0, the hop-by-hop option headers is only examined and processed by nodes along a packet delivery path if they are explicitly configured to process. So in this draft, we considering to signaling the nodes capability to process the hop-by-hop option header. So based on the RFC specified, we noticed that the nodes may be configured into several options. The first one, maybe it's configured to ignore the hop-by-hop options header. The second one is drop it, and another option is assign the packet to the slow processing path. So here we see that the problem is different devices can be configured to process the options header in different ways. And we found that there's a lot of service to use this hop-by-hop options header, such as the IOM, and another one is the alternate marking measurement. So so we think that if nodes are not configured to process this option header, they may ignore them or drop this service package. So it will result it will not account for all links to performance measurements and will result in the packet loss. So this document and defines a way to signal the configured processing action of this hop-by-hop options header, and using the ISIS and the OSPF. So by advertising this information, this can be helpful for entities to gather this information, and based on this topology to calculate the passes for specific services requires the hop-by-hop options header. Next page, please. So in this draft, we first defined the hop-by-hop options header processing action. As we see in this, the first figure, we defined the hop-by-hop processing action information formed of 3 fields. The first one is the 8-bit action flag field, and the second one is the 8-bit maximum extension header length field, and the last field is the 16-bit service flag. So the action flag, we use the highest order 3-bit to indicate the supported processing action, and the max extension length field, we indicate the maximum length of the extension header can be examined and processed and node or link granularity. And the last field is service flag. It's to indicate the supported services requires the hop-by-hop options header. Here we defined 2 bits. The first one is to the IOM trace option, and another bit is the alternate marking method. And the other bits we will reserve for future use. Next, please. So based on the definition of the processing action information, and here we propose the extensions to the ISIS protocol, and we defined the node processing action sub-TOVs sorry, extended to ISIS router capability TOV. And another extension is the link processing action sub-TOV and to indicate the actions of the interface associated with the link. So in this document, because we defined the node and link processing action TOVs, and we need to mention that if all the interfaces associated with link supported the same processing action, so we need just to advertise the node capability TOVs. Yeah, and the list page we show the signaling processing action using the OSPF. Similarly, we extend the node processing action TOV and the link processing action sub-TOVs extended to the OSPF router information pack LSA, and for the OSPF version 2, we defined the link processing action sub-TOVs of the extended link TLV, and for the OSPF version 3, we extended to the eRouter LSC TLV. Next please. Yes, this is all the content in this draft, and the comments are welcome. Thank you.
Chris, go ahead.
Yeah. Hi, Ali. So this
Hi.
reminds me a lot. This reminds me a lot of the iFit one, which I also sort of had issues with. I noticed the latest iFit draft now mentions using the information for path computation. One of the complaints before was that this was sort of, you know, capability stuff that had to do with OAM and not routing, right? And so it wasn't appropriate to put it into the routing protocol. So, you know, I guess my first question with a follow-up based on your answer is, are you going to use this to determine routes through a network?
Thanks for your questions, and thanks for your comments for the iFit draft in the last meeting. And for this draft, we want to mention the motivation is to advertise the hop-by-hop processing action, not the iFit capability. So this is not the same the problem we think, and because we considering the nodes or the interface supported the processing action for the hop-by-hop header, it may affect the path computation. For example, if we have the service using or requires the hop-by-hop header options, we need to determine or we need to know which nodes or links supported to process this extension header. So this is not the same. I mean,
Right,
it's
okay.
not the same with the iFit capability.
Yeah, no, I understand it isn't, but I'm just thinking, I'm putting to throw like an operator hat on, and I'm looking at this and I'm wondering, like, you know, I buy a bunch of routers, and you know, and I want to do OAM on them, and do I really want my traffic being determined by whether I've upgraded my line cards, or do I want to just upgrade my line cards and then use my OAM software, right? You know, I'm not sure I believe the use case that, you know, that I really want my network paths being determined by whether I've got an updated line card or not. I mean, I'm not saying that it wouldn't happen. It's just, it feels a little funky. That's all. Thanks.
Thank you.
Okay, Loa, are you in queue, Loa?
Question on slide number 4.
Okay. I guess I'm in queue next. So these OEM techniques. I didn't look them up, but they're in-band techniques, right?
In situ, yeah.
In situ, yeah, in-band. Okay.
Yeah.
And so the basic proposition that Chris was getting at is that you're going to compute only those paths that support these OEM techniques, because you need the performance data to measure your SLAs or something of that nature, I guess. Okay, you go ahead, Ron.
Yes, that is the one case we mentioned in the draft. But I think there's a lot of use case use the hop-by-hop options header.
Okay.
Yeah.
Yeah, but the only ones you have bits for are the OAM techniques. So those would be the ones you're advertising today.
I think we need to cut the line.
Right. Okay.
Ron, go ahead.
Yeah, go ahead.
If the only application for this is path computation, couldn't you achieve the same thing with link colors?
Yeah, Ron, actually, I want to answer that. That's what I thought. I thought, like, okay, so I've got line cards. I just mark my interfaces that support this, right? And I'm done.
That's where I was going with it.
G, you're up last.
Yeah. This is Jadong, and to my understanding, this document aims to advertise some generic attribute of the packet processing capability regarding the hop-by-hop option headers. I think there are also other use cases in addition to the IOM or iFit functionality, such as some traffic which may need to carry the hop-by-hop option header for some processing behaviors required on each hop along the path. So we have another draft in the 6 months actually related to this hop-by-hop option header extension. So I think this can be a generic mechanism. And maybe some application would require to select the route based on this capability.
Yeah, maybe we can see how that goes as that moves forward to see if there are, if that moves forward, some other options. We've got to move to the next presentation now. We're going to run out of time. Thank you.
From what I understand, I think Jian's going to present for the offers. He's in the queue.
Huh. Let's see how that works.
Yeah. Or I see.
Hello?
Ivan's in the queue too.
Hello, I see.
Are you presenting?
Yeah, let me try to make a presentation for the passive interface attribute.
Okay.
Go ahead.
Thank you all.
Okay.
Thank
okay.
you.
So this is the third time to make the presentation. So next slide. Yeah, so we want to here to mention what we want, what's the proper one to show. We know passive interface are used commonly in the network. Here we just list three scenarios. The first is in the data center, so they are used for the VLAN interface. They serve in the layer 2 broadcast domain. And the second scenario is for the interface boundary. They are used to protect each domain from IGP flapping as called by our domain. And the last scenario is described in one draft that provided by Linda for the edge computing scenario. I think it is the same as the scenario as the AC has just created. But currently, there is no suitable place to advertise the passive interface and their associated attributes. So we want to find some place to put this information in the protocol. Okay, next please. We also investigate the existing possible solution. For ISS, they have defined the one link attribute sub-TLV, but this sub-TLV can only be carried within the TLV22. This TLV is used to describe the attached router, but for passive interface, there is no IGP router, so it is not suitable for the information to contain in this sub-TLV. OSPF v2 also have one link type within the router LSA. The type 3 can be used to flag the passive interface, but there is no other place to put the interface attribute. And OSPF v3 has removed the type 3 link type. So, as we said, it is necessary to extend the OSPF v2, v3, and ISS to transfer the passive interface and their related attributes. Okay, next please. So here is the OSPF v2 extension proposal. Currently, RFC 7684 defines the OIP v2 extend the link opaque LSA to contain the additional link attribute TLV, and only the extend the link TLV is defined. So we propose defined one extend stub link TLV to contain the sub TLV that's related to the passive interface attribute. This is the format of the TLV, and the existing sub TLV defined in the IETF registry can also be included if necessary. We have defined one new sub TLV in the I will describe it later. Our next slide. So this is for OIPv3. For IPv3, the define the it is defined the LSA in TLV tube, so it is easy to expand. We propose to define the router stub link TLV to describe a single literal passive interface. As the router link TLV, this TLV should only be contained within the extension router LSA. It can also reuse the existing sub-TLV that's defined within the related OSPF registry. Next slide. This is for the ISS extension proposal. For ISS, as we have discussed on the main list, we can only define one new top TLV to contain such information. So we define the TLV as this format, and the existing sub TLV can also be included if necessary. So next slide, please. So in this document, we define one new sub TLV to contain the IP address information that associated with the passive interface. For example, the server's interface address. There may be several addresses to associate to connect with the passive interface. So we use the existing sub-object to include this information. And we also, because this sub-TLV and the future new sub-TLV that associated with the sub-link can be both applied to the OSPF and the ISS. So we propose to define one independent registry code point, which can be referred by both IGP protocol. So next slide. This is for the prioritization. So and we also discuss on the main list. So here just want to is there any other comment for this draft, and can it be adopted as the W working group document? Thank you.
Okay. Oh, well, I'm in the queue. I wanted to back up just 1 second. The previous, my previous comments on the other presentation, Yali, those were made as a working group member. I'm supposed to say that each time, and I sometimes forget. So it was just my working group member, as well as these comments are as a working group member. You know, I'm curious about some of the use cases. It seemed like on the mailing list that there was like one use case where it was inter AS, and that you know, there was some discussion that was already covered by TLV. And then there's a reference to like Linda Dunbar's draft, which I went and read, which was about sort of like using passive interfaces to describe loading on servers with Anycast addresses. And in that case, it's like, you know, why wouldn't you just advertise the Anycast as a prefix and attach that, you know, the attributes to that prefix? Why would you call a server a link? So anyway, it just seemed to me like it seems weird to be using a link in these cases when, you know, if it's inter AS, there's already something for that. And if it's servers, then why not use the, you know, prefix? Thanks.
I think the information provided by the draft described by Lida is connected to the Skype link. So I think they are suitable to put into this passive interface attribute.
Yeah, I guess my point was I think that draft's wrong. It's describing a server and an Anycast address, and then trying to attach the information for it to a link. That just doesn't. Why not just do a prefix for the server? But, okay, we can discuss it more in the list.
Okay.
AC, did you have a comment?
I'm gonna be quick too. The thing I'm thinking here, rather than coming up with a generic way of advertising that it's a stub link, you're using the fact that it's stub link to make inferences for these use cases. Why wouldn't you just advertise, because what that you have this inner AS thing, why wouldn't you just advertise this as an inner AS boundary or something like that, or whatever your use case is? And we can discuss this on the list too. I think this is just when we have 9 minutes left and you got one more presentation.
Okay, let's discuss in the main list.
Yeah. Thanks, and I'll review the update. I'll take a look at the updated one. I see you just updated it in the last.
Okay.
You told me you were going to do this, but when the window opened up.
We have updated the draft, but I not seen the notification on the main list.
Yes.
Okay, next up. We have 8 and 7 minutes. Sorry.
Can you hear me?
Yes.
Yes.
Okay. All right. So this draft PUA prefix unreachable announcement. Go ahead. Next slide. So the motivation behind, so really the main problem statement, I guess, where this draft can be beneficial is in cases where you want to have a converge the data plane. So like, so instead of, I guess, relying on control plane convergence to speed up the data plane convergence. And one of the really the big use case for this would be for, and if you have a, your BGP next hop attribute convergence. So let's say if you have external peers and where you're marking your BGP next hop, going to next hop self. So in that particular case, and you have a link failure, being able to detect that link failure quickly with a advertisement, with a negative advertisement saying the link is down, and allowing your if you're running, let's say BGP like PIC core in the core, your hierarchical fib can converge quickly, noticing that data plane failure, and then you're able to converge quickly. Another use case for this draft is with summarization, where you have a area, a IGP domain that's subdivided into multiple areas, and you want to be able to switch the data plane convergence from one ABR, your primary ABR, to the secondary ABR. So that's another use case. And then within an area, either link or node failure. So intra-area link or node failure, and being able to, with this negative advertisement, this prefix unreachable component. So when a component prefix goes down, being able to converge that data plane quickly. Next slide. Go ahead, next slide, thanks. So this is a typical, just a service provider core. You have edges, yeah, there you go. Yeah, just that one. Sorry, the previous one. Yeah, there you go. Okay, so let's say you have a typical service provider core, and where you have edges to, you have BGP overlay services, and you want to converge the core quickly. And where you're running, let's say, BGP PIC edge at the edges, and you're running, let's say, BGP PIC core, but the hierarchical fib, you're doing a next hop self to the route reflector. So in that case, you're rewriting the next hop to the loopback, but the loopback is always up. So you're in the core. Your core doesn't converge as quickly because you've done a rewrite to the loopback. It's something that's kind of really existed day one, you know, with pick core, and to work around that, what you end up doing is you end up having to advertise all of your external prefixes into the core, which creates a bigger fib. So this workaround, what it does is with this negative advertisement, it converges that data plane quickly. So now you're doing this prefix unreachable advertisement of that link that's down, and you're able to converge the core quickly onto that onto the new path. Next slide. So this is a topological layout of a multiple areas where you actually have the PUA convergence with multiple areas. Go on to the next slide. Next, yeah. So here in this scenario, this is an inter-area scenario where you have two ABRs. So in the center of the diagram, you have router 1 and router 3, router 1 or router 3 or router 2 or router 4, and they're both ABRs or L1, L2 routers, and you have a link failure when that happens within the area, or a node failure. In this case, we have T1, you know, went down on the left, on the right side, and here we have S2 on the left side. So in that case, what ends up happening is you end up having a summary advertisement that gets advertised by the ABR. So like on the right side, you have route R2 and R4, that'll advertise a summary back towards area 1. And on the left side, you have S2 went down. So you have router 1 and router 3, they're advertising a summary. So in that particular case, where S2 has gone down and the prefix is no longer reachable, you still have traffic that kind of heads back towards S2. You know, comes up to R1 and R3 if they're both active primary. And then the same in the other direction. You would get an ICMP back the other way, but you got traffic going in that direction. The other caveat and part of the problem statement is cases where you have component prefixes that are part of a summary, where you have a false positive that happens where the components are there, but then let's say the component disappeared and there's no component prefixes, but the summary route is still advertised. So in that case, you made black hole traffic in those cases. So what this does is with this negative advertisement, it converges the data plane quickly, so you don't risk any black hole traffic. Next slide. So in this case, this is the inter-area scenario. So where you have a node on the right side, T2 has gone down, and you have so you still have a summary route advertisement that gets advertised by R2 and R4 into the backbone area 0, and then back over to area 1. And then so on the left side, you have the summary gets advertised back over, but now because the node T2 is down, you have traffic that'll flow because the summary is still present. So you have traffic that flows up to R4. R4 will send an ICMP back, but you have that data traffic that comes over to R4. So in a scenario where, let's say there is the network is partitioned or something happened, let's say R4 is not reachable, but he was reachable for a period of time, but became unreachable, and the component prefixes were present, and they're present on R2, but they're no longer present on R4, and R4 is still sending the summary route. You end up having a situation where you end up black holing traffic. So with this, so go on to the next slide. So that's a use case with the node failure. Go on to the next slide.
We've got 1 minute left. I don't know if it'll cut us off or give us 5 minutes.
Okay, all right, thank you. Go on to the next slide. We'll just go into skip a couple slides. Go to the next slide. All right. So this slide, this is a case. That's fine. That's fine. Just keep it on this one. So with prefix unreachable advertisement, what ends up happening is when you have that node failure happen. So like on T2, the node failure happens. So now a prefix unreachable advertisement is sent, you know, from the ABR, so R2 and R4, they detect that and they send the PUA advertisement out through the backbone over to Area 1. Area 1 sees that, and then the route, when it's flooded out to Area 1, they install in the FIB, in the data plane, and that's where the data plane convergence happens, and null zero to black hole the traffic, so no traffic is sent to that route. And that's really for the ABR. So let's say if for some reason, let's say there's a partition network, R2 is down, he's no longer reachable. He doesn't have any component prefixes, but he's advertising the summary for whatever reason, because there was maybe a race condition or something, but he's advertising the summary. R4 is still up, but we don't want any traffic to go to R2, black holing traffic. So in that case, the data plane, it converges on the left side. So the routers on S1, S4, S2, and S3, they end up, port programming into their FIB to black hole that LSA that's advertised to set the next hop to all zeros. So basically, not using that summary advertisement for that prefix. So no traffic goes to that prefix. Go ahead, next slide.
We're going to get cut off soon.
Okay. I'll just talk until it cuts off. Go ahead. Next
Well,
slide.
I mean, maybe people have comments. I don't know.
Yeah, go ahead. Actually, why don't we just do some Q&A, I guess, right now. That would be fine. Since we don't have much time left. I'll just talk through this last slide, actually, if you don't mind, and then
say which one. You're a few seconds behind when I switch them.
Okay, sorry. Go to the next one, the last slide. Okay. So with this prefix unreachable advertisement, there is a feature called maximum advertisement, which in a case where you have prefixes, and this is something that could possibly happen, where the number of reachable prefixes and unreachable prefixes, there are more unreachable component prefixes than reachable. So in that case, it makes the summary advertisement even more conditional. That typically, if you have a single component route, the summary is always advertised. So in this case, there would be another factor, another variable that allows you to would be able to configure so you don't always advertise, and you could switch to only advertising longer matches. So it's just another layer of conditionality, I guess, with the summary route. So that's pretty much it for the slide deck. If anyone has any questions, we can go ahead and go to questions.
Well, something occurred to me as speaking as working group member when I was thinking about this. A lot of people seem to have complaints about the mechanism for withdrawing the unreachable, using timers and whatnot, and how it was, Rift, it was compared to Rift, and how Rift had a more deterministic way to deal with it. It made me think, if there was a way to attach the unreachable to the summary route, so that then you would just re-advertise the summary route with or without the unreachable, the holes, basically, right? And that way, you don't have that problem of timing out. That was just an idea I thought of. I don't know how I don't know if you're able to do that like in OSPF and stuff.
Right. So with this, let's say when they route the prefix unreachable advertisement, it would only be present when a component is down. So when that component comes up, the unreachable, it stops immediately. So it wouldn't stay, but it would help. It would help for, propagation. But when the summary is advertised, it would be the summary plus this component. So it would be attached to the summary route. So when the receivers, I guess, on the other side, when they, let's say on the left side, let's say when they receive the summary, they'll see the routes, the components that are down, and they'll automatically program it in. But let's say program into the FIB to stop, to drop traffic and not send any traffic to that summary route.
Right. I was just saying, if you have it as a sub TLV, then you can withdraw it by just changing this summary again, right? I think we're going to get cut off in 10 seconds. AC, do you want any last words?
That's it. I mean, I think we just pick it up on ML, on the mailing list.
Yeah. I was just going to, speaking as working group member, I was going to say there's a lot of complexity here for the different use cases, and it looks like you even added some additional use cases in your slides.
And the interaction with the rib is going to be quite complicated. That if you should describe what you'd expect to be installed in these cases, and how it's going to work, because I look at it and I said, oh, yeah, you know, I can kind of wave my hands and say how it works. I think that needs to be specified.
Yeah. I mean, I think that piece of it, with the convergence, and let's say, you know, if you have a false positive or false negative, I think with timers, because you're impacting the data plane, it's supposed to make the convergence better, not worse. So we want to make sure that whatever timers, that we make sure that the when services come back, that, and it would be a flood, that it would be part of the summary. So when the service comes back up, it's immediately flooded and removed. So you converge immediately as soon as, and it would be part of the same summary advertisement, same sub TLV. So when the service is back, it comes back. When it goes down, the data plane converges immediately on that component that goes down. So just, and it's for a link or a node failure, but really improving the data plane convergence. I think the big one that I think, you know, overall, like, you know, on the mailing list, I think that came up with the BGP, which could be like in this drawing, we actually have multiple areas, but if you had a single area and that issue with the Nextop self on your tie to, let's say, you know, other, you know, customer ASs, where, you know, because you're doing that Nextop rewrite, your BGP, like prefix independent convergence, your core, pick core, because that hierarchical fib, that now it's dependent on the loopback, doesn't go down. So that kind of impact, and that's something that's always existed for a long time. So this thing would make the that next hop reachability, that the next hop, you know, where when that PEC links goes down, now you're converged immediately. And I think that would be like a huge gain, and it would be really for any service provider or operator that you have where you have that tie, but now you actually converge that data plane quickly when that next hop goes down. So, I mean, I would say overall, that's probably the biggest one. I mean, I think the timers, and I guess really converging the data plane and making sure that when services come up, we just have to make sure that that entry that's tied to the prefix, the component prefix, that it's gone, and it would be a flood, so that IGP would flood that LSA out. And, you know, and with this new TLV, but it would age it out quickly. Like it would be immediately flood, that as soon as the service comes up, boom, that black hole route is gone, the unreachable is gone. As soon as the component, you know, as soon as the component is down, you know, as soon as it's down, like the next hop goes away, then immediately the data plane converges. As soon as that next hop comes up, then immediately it's withdrawn. Basically, the PUA has to be withdrawn. So it would really have to be immediate, you know, and it can't be that it's lingering, or any case of a false positive or false negative happening. I mean, that's really the critical one, because we don't want to make things worse. We want to make it better and improve convergence.
Okay. Well, somehow we got more grace period than I thought we did.
Hey, Adrian, are you still there? I don't know if you want to comment or anything on the draft, I guess. Any other comments that you want to make?
Well, yeah.
And then we went over too. We're at 202. A little bit of grace.
209.
209, yeah.
Okay.
I think this probably needs a lot more discussion on all this. We're sort of mid-discussion on it, it feels like.
I do too, and the different use cases have different. This is AC again speaking as working group member. They have different behaviors.
Yeah.
And so mixing them is confusing as well, and saying you just can do them all.
Right. No, it is. I mean, I think there's some stuff I think we have to really, you know, clarify and just kind of, you know, clean up some of the verbiage in the draft. But I agree, the mix, there is a mix of use cases with the areas, you know, convergence and all. But I think some of that we'll have to work on cleaning that up, you know, in the draft.
Tony, did you have something to say while we're still able to talk?
Yeah, I have a concern about scalability. seems to me like if you had a significant failure, you could use this to inject a whole lot of stuff into your IGP relatively suddenly. That seems like an unintentional stress test.
Yeah, so Tony, that's a good point, but I think that is something that we would control with there's a timer that we would have, and it's a variable that's really based on, and I think it would be a user configurable, like based on the number of component prefixes that are down versus the number that are up. So how many negative components you have and how many services are up. And it would be something configurable based on the prefix length that user configurable. So depending on, and it would be really like, let's say if you have, I think like by default, as long as you have one match and there's one component that's up, the summary always gets advertised. So you could keep it the same, or you could change it, and that's a variable that you could change depending on the use case. That if you don't want it to change and you want to like always advertise it summary no matter what, even though you're just, let's say you have 1,000 component prefixes, but as long as one component is up, you always advertise it. And that's something that you could change. You could say, well, make it like 50%. If you have 50% of your components are down, really, you shouldn't be sending out the, summary. Maybe at that point, send out your components, because there's a lot of downstream failures. But it would be something that would be user configurable. Hope that answers the question, Tony. Anyone have any other questions or comments? And we can pick it up, I guess, on the mailing list. How does
There's been comments before too about we let it run over, but we shouldn't let it run over too far because people may have other things scheduled. So I think we should probably wrap up.
Yeah, we're supposed to leave a grace period between the next meeting starting at 2:30 Eastern Standard Time.
Yeah. Okay.
How did my voice sound, I guess, now? Like I'm just going directly to the PC, but I'm like talking like really close to the mic. Does it sound any better, or is it still low?
Yeah, you sound fine. AC, I think we should wrap up.
Yeah, I think so too. So we'll
Okay.
continue this discussion on the list. Sorry to Parag and Kayer, but
all right. Well, thanks everyone.
Thanks everyone.
Seemed to go pretty well.
Yeah.
Thank you.
Yeah, this was better than the last online meeting.
Yeah, I agree.
Yeah.
All right. Ciao.
Yeah.